The Bering Sea and Strait is located between Alaska and Russia. Bering Sea and Strait, Russia Berengovo More and Pearly Beringa, northernmost part of the Pacific Ocean, separating the continents of Asia and North America. To the north, the Bering Sea connects the Arctic Ocean through the Bering Strait, at the narrowest point of which the two continents are about 53 miles or 85 kilometers apart. The boundary between the United States and Russia passes through the sea and the strait. The Bering Sea also provides habitat for many whale species, including bowhead whales, beluga whales, grey whales, orcas, and the humpback whales. Other marine mammals that use the Bering Sea including walrus, bearded, spotted and ringed seals, and polar bears. It is a home to a diverse array of marine life as well as the largest fisheries in the United States. It is one of the most productive marine ecosystems in the world. The region is also home to indigenous Alaskans who have been part of the ecosystems for millennia and have traditional knowledge gained from their subsistence way of life. In the Bering Sea, science-based management of major fisheries is designed to control fishing at levels that maintain stable populations of valuable fish. But a single-species approach to managing fisheries does not always consider the interconnections among marine organisms. Many scientists argue that although good single-species management is necessary, fishery managers also need to look at the bigger picture.
Next, I will describe about the ecosystem and biodiversity of the Bering Sea. The Bering Sea is a sizable, contained subarctic sea that is bordered by Alaska's southwest coast, Russia's Chukotka and Kamchatka peninsulas, and the Aleutian archipelago. It is one of the world's most productive marine ecosystems. And do you know that an active and fruitful environment, the Bering Sea supports around 40% of the commercial fishing catch in the United States. But there have been noticeable ecosystem change that are thought to be caused by climatic and oceanic variability. Change in seasonal sea, ice timing and extent, coccolithophore bloom incidence, groundfish species strength and recruitment patterns, and seabird and mammal population fluctuation are a few of these. It is currently one of the world's most prolific and diversified marine bodies. The Bering Sea is home to millions of seabirds, representing more than 50 species, 19 species of whales and dolphins, 10 other marine mammal species, and more than 400 different fish species.
As for the method for ecosystem management, the North Pacific Fishery Management Council has adopted Bering Sea Fishery Ecosystem Plan, in short BSFEP. This plan has acted as a framework for continued incorporation of ecosystem goals and actions in regional management, in this case, the Bering Sea. Through this plan, the Council has presented two action modules, the first one being evaluating climate change effects on the fish, fisheries, and the Bering Sea ecosystem, and also develop management consideration. The second one is develop protocols for local knowledge, traditional knowledge, and also subsistence. The next method is species protection. The Council has protected forest species by setting and adjusting the catch limit to avoid overfishing. Examples of the forest species are yellowfin sole and Atka mackerel. After that, the Council also monitors and minimizes bycatch of non-target species that are important for the ecosystem. This is done by prohibiting direct fishing and maximum retainable allowances (MRA). The last method is by habitat reserve and protection. The Council has set aside over 520,000 square nautical miles of ecologically important habitats. The Council also protects habitats in the ecosystem from harmful impacts of damaging fishing gear, for example, the bottom trawls fishing gear. Lastly, the Council also predict natural occurrences so that the proper measures and initiative could be taken to protect the ecosystem from damage.
Assalamualaikum, I am SYAZANA and I will continue the presentation with the challenges in ecosystem management. First challenges is bycatch, which is the incidental capture of non-target species such as dolphins, marine turtles and seabirds. Modern fishing gear is very efficient at catching the desired fish species as well as anything else in its path. Solution is avoid bycatch hotspots, establish enforceable limits, and develop gear modifications designed to reduce bycatch. However, despite new technologies and industry recognition of the issue, bycatch is still a major problem. Bycatch is not only cause avoidable death and injuries, but the fishing methods can be harmful to the marine environment where they are employed. Next is habitat protection. Recent scientific information showing concentrations of deep sea corals and other ecologically important and sensitive habitats along the Bering Sea slope has led the Council to consider measures to protect these habitats from the harmful impacts of damaging fishing gear such as bottom trawls. Overfishing and destructive fishing have been identified as the greatest local threats to coral reef. Common fisheries management tools that control effort or catch are often prohibitively difficult to enforce for most coral reefs. Next challenges is climate change and related phenomena such as ocean acidification will alter the Bering Sea ecosystem and have significant consequences for all who depend on it, from cree to coastal communities. Reduction in sea ice, for example, can affect the seasonal bloom of plankton and reduce the productivity of the overall ecosystem. Understanding and predicting these changes enables decision makers to adapt fisheries management in order to mitigate and protect against the harmful impacts of climate change in the North Pacific. The last challenge is food web dynamics. Data collection and ecosystem modeling are providing greater understanding of important predator-prey relationships in the Bering Sea ecosystem. For example, new models are available to monitor and react to changes in the availability of forage species such as krill. As knowledge of these relationships grow, fisheries can be better managed to maintain the structure and function of this dynamic and productive ecosystem. That's all from us. Thank you for listening.